Solve the following system of equations. The first equation is a line. The second one looks kind of like what an equation for a circle would be, but it isn't a circle. It's a type of construct called a hyperbola. You don't need to know what that looks like in order to solve this. Effectively, all you need to do is know the algebra of how to set up a system of equations and solve. In this particular case, because we have a nonlinear piece, the substitution method is the ideal way to go. Substitution method says to take one equation and solve it for one variable. So I'm just going to take the top equation and write it as x equals 10 minus y, because I'm just subtracting y from both sides. Now, into the other equation, which is x squared minus y squared equals 100, I'm going to take what I have for the variable x and substitute it right into that variable. So this would be 10 minus y, quantity squared, minus y squared equals 100. Now, you could have solved the top equation for the other variable. That would be perfectly fine. You just would have an expression now, or an equation now, that includes only x variables. It's no problem. You'd still get the same answer in the end. Let's square this binomial out. So the square of the first plus 2 times the first times the second, so minus 20y, and then plus y squared. Okay, now it looks like I have a lot of things that will cancel, which is always nice. Y squared and negative y squared will cancel. 100 and 100, because if I subtract 100 from both sides to combine them, well, they just cancel out. So it looks like the only thing left right now is negative 20y is equal to 0. And if I divide both sides of this equation by negative 20, 0 divided by negative 20 is still 0. So 0 is one of my solutions, or part of my solution, that is. And to get the other part, the x value that's associated with it, then I let y equal 0, pick either of the equations above, and substitute that in. So x plus 0 is equal to 10, which means that x is equal to 10. So my intersection point between these two curves is at 10, 0.